It's very easy to get depressed over the scale of the problems, and you look at air pollution and water pollution and what's going on around us. If you look through human history, every generation has had to deal with what seem to be insurmountable problems. We have new problems, but we have new technologies. We have abilities and know-how and knowledge and the ability to continue to develop new technologies and new understanding that each time leads us to new levels. My main area of research is in hydrology and water resources, understanding how water and pollutants move underground in soils and in aquifer and geological formations. The vast majority of water on the planet Earth is, of course, the oceans. Even though we have large lakes and large rivers, of the world's fresh water, usable fresh water, over 97% is in fact underground. This is the water that we all use. Unfortunately, a vast majority is affected. First and foremost, again, we're over-pumping aquifers. On coastal areas, we over-pump the groundwater, the salt water moves in. You can have massive drops in land because of over-pumping. We have to preserve the resources we've got, and with industrial development, we're now polluting large amounts of the remaining water that we have. If we introduce various chemicals from industrial leaks or from use of pesticides, we need to know, how do the chemicals move underground? How do they interact with other chemicals? Do we have to worry about them? Do they pose a threat to us or not? And if so, what can we do about it to clean the water and to have safe water resources for use? On one hand, we look at polluted water, how it moves underground. Does it degrade naturally, or what can we add to the water there to try to improve the quality? On the other hand is looking at prevention. So we're looking very seriously at wastewater effluents in particular, and to say, can we treat the water so that it's then can be dumped or put back into reuse in a safe fashion? Each situation is unique. So we've looked at dozens of different kinds of industrial effluents, and we have a general family of catalysts, of materials we can use, for example, to degrade and clean the water. But each time we have to tailor it for the particular wastes that are involved. We started working with nanoparticles as potential contaminants, and we find the nanoparticles facilitate the reactions because they occur on the surfaces of the particles. So they're much more powerful, both in terms of the time it takes for the reaction to occur and for the total amount of degradation. We're talking about chemical degradation. We actually break down the materials into harmless byproducts. So I can take, for example, gasoline. We can break down the gasoline just into carbon, oxygen, nitrogen, hydrogen. Just into elements, no problem, no danger whatsoever. And the materials can then be reused. So it then becomes economically viable as well. We're now moving to a new area that are called technology critical elements. And this is now the discovery that rare earth metals and elements that are in cell phones and computers, in lights, in cars and headlights, right now they're being dumped in landfills. We don't even know these materials, how do they behave in the environment? So we're now doing basic research to say, how do these things, when they're released to the soil, what do they do? We need to understand why things happen and how things happen, because that's where the best solutions come from then. And the trick is not to try to solve a global problem. To understand the basic science, you come up with a result and say, hey, this is neat, what can I do with it? Canada, you say more water than you know what to deal with. Alberta is water rich in the north and extremely water poor in the south. I'm in Calgary, and there's very serious concern of water shortages within the next decade. So there it's a question of water distribution, not the total volume of water. So there's never a single magic bullet or a single solution to dealing with these problems. It's a question of conserving the water that's being used, treating wastewater to allow efficient wastewater reuse. This is Israel. We're world leaders in wastewater treatment and the reuse area, so we have a lot to contribute there. The scientists here, and certainly my own work, is motivated by wanting to know how and why things work. And once I know the how and the why, I say, okay, how can I translate some of these ideas into useful technologies or products or ways to improve the world around us? We all like fame and glory, and yes, you made a breakthrough result, but the bottom line is I'd like to see my technologies being used to actually clean up some of the messes that we're making. And the messes we're making are around the world. So wherever we can apply them will thrill me tremendously.